Hello everyone, this is Ramneep Singh and I'm here to help you learn robotics. First, we'll start with the very basics. That is, what software we are going to use during our sessions. The softwares which we'll be using are HID boot flash, that is this one, the one on which my pointer is, and the second one is WinAVR 200700525. Okay, so why these softwares? Because the microcontroller or the motherboard which we are using is AVR 8535. 85 is the series number and 35 is the frequency in kilohertz of the clock which is in the microcontroller. Okay, so now how the microcontroller looks like is this. It looks like this, and it's actually the motherboard, the entire motherboard, and this is the microcontroller, the one on which my pointer is. Okay, so it is having four ports, that is these. This side, the one on which my pointer is port A, then this is port B, this is port C, this, and this is port D. Each port is having 8 pins. These are the switches, this is the buzzer, and so on. We'll be learning about each and every part of it. Okay, secondly, this is your microcontroller. Okay, these are port A, port B, port C, and port D. Okay, so the main thing which you need to know is how to program using C++. I hope you all know this, so I won't be discussing this. Okay, this is how we'll do it. First, we'll include the header file, which is avr/io.h. It's not iostream.h, it's avr/io.h. Instead of void main, we'll be using int main with the void. So here are some new commands which you need to learn. That is port X, DDRX, and pin X. So what is X? X is the name of the port, like A, B, C, or D. Okay. So what is the use of port X? Port X determines the port which you will be using, and anything after 0x means hexadecimal and after 0b means binary. Okay, DDRX. DDRX determines the direction of current, that is input or output. Will the device be giving an output or it will be taking an input? Pin X determines the pin from which you have to read or write. Now while 1, anything written in this loop will run for infinite times and we need to use it very often. So here the main thing which you need to know is the hexadecimal conversion table. This is very important since everything will be writing in hexadecimal coding. So this is the decimal part, this is the hexadecimal part, and this is the binary part. In robots, everything which we'll be doing is directly connected to their memory locations and all. So firstly we need to learn what is a nibble. A group of 4 bits is a nibble, and but we'll be using 8 bits, that is divided into 2 halves. First half is the first nibble and second half is the second nibble. Secondly, since we are working with binary numbers, we need to know what does a 0 mean and what does a 1 means. 0 means that you are giving a low current and 1 means that you are giving a high current. 0 also means that you are resetting something and 1 means you are setting something. So let me give you an example first. Okay, so as you can see here, this is the buzzer. Okay, the one on which my pointer is, and buzzer is activated when it is given a high. Okay, and buzzer is connected to port C3. This table, this configuration table, gives the parts which are connected to some ports and all, everything which is connected to a particular port, and this is the configuration. Like the buzzer is connected to port C3, the switches are connected to port A, 4, 5, 6, and 7, and so on. And buzzer gets activated when it's given a high. Okay, that means we need to give it 1 So where is buzzer? Buzzer is at port C, third pin. So these are the memory locations and all. This is how it is configured. It's in descending order 7 to 0, and we need to give C, port C, third pin a high. So we give it a 1, and all other pins are given 0. Why 0? Well, that doesn't actually matter. You can give it a 1 also, but it will not change anything. So, since it is divided into two parts, that is two nibbles, 7241 and 320 is the other. In hex, it will mean 724 is 0 and 320 is 1. 320 is 8. So, to determine the pin, we'll write port C is equals to 0x08. That is, every current flow will be from the third pin, that is 8, 0x08. Okay, and since the work of the buzzer is to buzz, so it's an output for us, so we'll give it a 1. So in DDR we'll declare it as 1, that is DDR is equals to 0x08. So this was our first session. Next time I'm going to tell you how to program it using the software which I'll be providing you. You can mail me at ramneeksingh1992@gmail.com. I'll even put it up in my post. Plus, if you require anything, just contact me. Thanks a lot.